It is generally not permissible to run phone and power lines in the same conduit due to curb restrictions and safety considerations. Electrical codes, such as the National Electrical Code, have specific requirements regarding the separation of power and communication circuits. The primary reason for this separation is to prevent electrical interference and ensure safety. Power lines carry significant voltage and current, which can induce voltage in nearby communication cables. This induced voltage can disrupt phone signals, creating noise and potentially damaging equipment. It is important to understand the electrical code requirements. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Article 800 addresses communication circuits. These articles contain provisions that may prohibit the mixing of power and communication circuits in the same conduit. Specifically, Section 725.136 addresses separation from electric light, power, Class 1, non-power limited fire alarm circuit conductors. This section typically requires that Class 2 and Class 3 circuits be separated from these other circuits. This separation can be achieved through various means such as physical barriers, grounded metal conduit, or by maintaining a specific distance between the circuits. For communication circuits, Article 800 generally requires separation from power conductors. Section 800.133 provides details on grounding and bonding requirements for communications circuits. It also addresses separation from other circuits to prevent induced voltages and interference. In general, you should maintain a separation of at least 2 inches between power and communication cables when they are run parallel to each other. When crossing, they should be separated by a barrier or enclosed in conduit. The type of conduit used can also play a role in maintaining separation. Metal conduit provides better shielding against electromagnetic interference than non-metallic conduit. Therefore, using metal conduit may be a requirement in certain situations where power and communication cables must run in close proximity. In some cases, it might be permissible to run low-voltage power and communication cables together, provided that they are properly insulated and shielded. For instance, Class 2 power-limited circuits, as defined in Article 725 of the NEC, are often allowed to be run with communication cables. However, this is subject to specific conditions and limitations. For example, Section 725.55 outlines the requirements for Class 2 and Class 3 circuits. These circuits must be supplied by power sources that meet certain voltage and current limitations. Additionally, the cables used for these circuits must be listed for the intended application. Proper grounding is crucial for both power and communication circuits. Grounding helps to prevent voltage buildup and provides a path for fault currents to flow safely back to the source. In the case of communication circuits, grounding also helps to reduce noise and interference. Section 800.100 provides specific requirements for grounding communication systems. These requirements include the use of a grounding electrode conductor, which connects the communications equipment to a grounding electrode system. It's important to consult local amendments. Local jurisdictions may have amendments to the National Electrical Code that further restrict or clarify the rules regarding the separation of power and communication circuits. Therefore, it's essential to check with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. Always consult with a qualified electrician. If there is any doubt about the legality or safety of running phone and power lines together, it's best to consult with a qualified electrician. A licensed electrician will have the knowledge and experience to assess the situation and provide guidance on the proper wiring methods. They can also ensure that the installation complies with all applicable codes and regulations. If you are dealing with existing wiring, proceed with caution. If you encounter existing wiring where phone and power lines are run together, it's important to proceed with caution. Do not attempt to modify or repair the wiring yourself unless you are a qualified electrician. Contact a licensed electrician to inspect the wiring and make any necessary corrections. Consider alternatives. If it's not possible to run phone and power lines in separate conduits, consider alternative wiring methods. For example, you could use wireless technology for either the phone or power connection. Wireless technology eliminates the need for physical wiring and can be a convenient solution in certain situations. However, be sure to consider the security implications of using wireless technology. Surge protection is another important consideration. Power surges can damage sensitive electronic equipment, including phones and computers. Therefore, it's a good idea to install surge protectors on both the power and communication circuits. Surge protectors can help to protect against voltage spikes and prevent damage to equipment. Follow best practices. When installing electrical wiring, always follow best practices. Use high-quality materials such as conduit, wire, and connectors. Make sure that all connections are tight and secure. Label all wires and cables clearly. And always test the wiring after installation to ensure that it is working properly. Proper installation of electrical wiring is essential for safety. Improperly installed wiring can create a fire hazard or electrocution risk. Therefore, it's important to take your time and do the job right. If you are not comfortable working with electrical wiring, hire a qualified electrician to do the work for you. Safety is paramount when working with electricity. Always turn off the power before working on any electrical circuits. Wear appropriate safety gear such as insulated gloves and eye protection. And never work on electrical circuits in wet or damp conditions. Understanding the specific voltage and current limitations of the circuits involved is also crucial. For instance, Class II circuits, as defined in the NEC, have specific voltage and current limitations that allow them to be run with communication cables under certain conditions. However, exceeding these limitations can create a safety hazard. The type of insulation used on the wires and cables is also an important consideration. The insulation must be rated for the voltage and temperature of the circuit. Additionally, the insulation must be resistant to moisture, chemicals, and other environmental factors. Using the wrong type of insulation can lead to insulation breakdown, which can create a fire hazard or electrocution risk. Proper bonding is also essential for electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault currents to flow back to the source. This helps to prevent voltage buildup and reduces the risk of electric shock. Section 250.92 discusses bonding other enclosures. When running multiple circuits in the same conduit, it's important to consider the ampacity of the wires. The ampacity of a wire is the maximum amount of current that it can safely carry. The ampacity of a wire is affected by several factors, including the size of the wire, the type of insulation, and the ambient temperature. If you run too much current through a wire, it can overheat and cause a fire. NEC Table 310.15 provides guidance on ampacity ratings for conductors. Adhering factors also come into play when you have multiple current-carrying conductors in a single raceway. Adhering is the process of reducing the ampacity of a wire to account for the heat generated by other wires in the same conduit. The NEC requires that you direct the ampacity of wires when there are more than 3 current-carrying conductors in a conduit. The amount of adhering depends on the number of conductors and the ambient temperature. When installing electrical wiring in a commercial or industrial building, it's important to comply with all applicable codes and regulations. This may include the National Electrical Code, as well as local building codes and fire codes. Failure to comply with these codes can result in fines, penalties, and even legal action. Proper documentation of electrical wiring is also important. This includes keeping records of all wiring diagrams, circuit schedules, and inspection reports. Proper documentation can help to troubleshoot problems and make future modifications to the electrical system. The use of appropriate connectors and fittings is essential for a safe and reliable electrical installation. Use connectors and fittings that are listed for the intended application. Make sure that all connections are tight and secure. And protect connectors and fittings from moisture and corrosion. Proper labeling of electrical panels and circuits is also important. Label each circuit breaker with a description of the circuit that it controls. This can help to prevent accidental shutdowns and make it easier to troubleshoot problems. Regular inspections of electrical wiring are important to ensure that it is in good condition. Inspect the wiring for signs of damage, such as cracked insulation, loose connections, and corrosion. If you find any problems, have them repaired by a qualified electrician. The use of arc fault circuit interrupters, or ASIs, is becoming increasingly common in residential buildings. ASIs are designed to detect arc faults, which are a common cause of electrical fires. ASIs can help to prevent fires by shutting off the power to a circuit when an arc fault is detected. Ground fault circuit interrupters, or GFCIs, are also important safety devices. GFCIs are designed to detect ground faults, which can cause electric shock. GFCIs can help to prevent electric shock by shutting off the power to a circuit when a ground fault is detected. In areas where there is a risk of explosion, such as in chemical plants or refineries, it's important to use explosion-proof electrical equipment. Explosion-proof equipment is designed to contain any explosions that may occur inside the equipment. This helps to prevent explosions from spreading to other areas. When working with high-voltage electrical equipment, it's important to take extra precautions. High-voltage equipment can be extremely dangerous. Always wear appropriate safety gear, such as insulated gloves and a face shield. And never work on high-voltage equipment alone. The use of electrical testing equipment is essential for troubleshooting electrical problems. Electrical testing equipment can be used to measure voltage, current, resistance, and other electrical parameters. This information can help to identify the source of a problem and make necessary repairs. Regular training on electrical safety is important for all workers who work with electricity. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Ongoing education is also important to stay up to date on the latest electrical codes and regulations. Finally, remember that electrical safety is everyone's responsibility. By following safe work practices and complying with all applicable codes and regulations, you can help to prevent electrical accidents and injuries.